Hello everyone, welcome to CivilPrep. So this is one of the session on MentorQuest at the rate 500. Okay, so this is a session for the students or aspirants who are appearing for Mains 2026. Okay, for Mains 2026. So this is a geography optional live answer writing session where we'll be in the live session discuss the various questions, answers, and the approach to write the answers along with models, theories, and perspective. Okay, so the first question here we have that evaluate the role of direct and indirect sources in deciphering the composition and physical state of Earth's interior. So this is one of the topic from the interior of Earth, which comes under geomorphology, under paper one, okay, under physical geography. Okay, now read this question again. Evaluate the role of direct and indirect sources in deciphering the composition and physical state of Earth's interior. Now take 7 minutes and try to write this answer. We'll discuss this. Okay, friends, you can pause here and you can write the answer and you can share it me in the group. So we'll be discussing answer here. So here we have certain uh, keywords That is direct and indirect sources. That is the keyword number one. And deciphering the composition and physical state. Number two, of the Earth's interior. So here we'll be seeing that the Earth's interior, it is a foundation to the geomorphology and plate tectonics. Since direct access is limited, thus direct access to the interior of Earth is limited in the form of rocks, volcanic ashes, and lava, but a larger access is achieved through indirect sources like seismic waves. Then here we also have gravimetric data, geothermal gradient, and geomagnetism. So through these aspects, we can understand thus we can understand the composition and physical state of Earth's interior. Okay, so through this short introduction, we can write our answer. Okay, we can start our answer where we are trying to explain that yes, we have certain sources and the limitations of direct sources which are overcome by indirect sources. But yes, there are certain limitations of indirect sources which we'll be covering in the next aspect. Now, first we'll be looking at a model that how is our interior of Earth is like. Now, here if we will see that this is okay, we have another model here. This is our core, that is inner core. This is our outer core. This is mantle layer, and this is crust. So in this model, we can see that we have the various layers, okay, of the Earth, and this is the basic interior of Earth. But how we can understand that this particular condition is present with respect to the Earth, okay? So here first we'll be looking at number one, the direct sources. So under the direct sources, we have a certain volcanic eruption. So under the volcanic eruptions, we have xenoliths and nodules, which are brought to the surface by the eruptions, which gives us an idea about the mantle composition. Under this, will be seeing an example, that is the kimberlite pipes in South Africa. Okay, which contains diamonds at the depth of 150 kilometers, which is basically part of upper mantle. Okay, so here we'll be seeing that there is a geomorphism activities taking place here. Next thing we'll be seeing that we have drilling projects. So looking at certain drilling projects like Pola, Super Deep, Borehole, which is present in Russia. Okay, approximate depth of 12 kilometers. Okay, so here we'll be seeing that the geothermal gradient, it is almost around 2.5 degrees Celsius for 100 meters. So this was one of the evidence which is collected in the region. But there is certain limitation. The limitation is it just represents the crust and upper mantle data only. Okay, and cannot go into the deeper core or deeper mantle. Now, next we can see here the part of indirect sources. So under indirect sources, the first source here we have, which is the most important source, that is seismic waves. Now, seismic waves, under this we have body waves and surface waves. Under body waves, we have P waves and S waves. So these P waves and S waves, they play a quite important role in understanding the interior of Earth. As we can see, the P waves, it can go through solid, liquid, and gas, while the S waves, they can pass just through the solid material. So this helps us in understanding the composition along with the composition with respect to the change in angle of refraction. We can also look at the density of layer. Okay, so through this, what we will see here that there is presence of various discontinuities. So under discontinuities, here we have number one, Muhoveric discontinuity, which is basically present between crust and mantle. Okay, there is increase in the velocity of P waves. Apart from this, we have Gutenberg discontinuity, which is present between mantle and outer core. Here we'll be seeing that number one, the S waves are stuck, while the P waves, its density, its velocity again increases. Number three, here we have next is Lehman discontinuity, present between outer core and inner core. Here we see that the P waves behave like in solid medium. Okay, so here we can see that there is identification of three different discontinuities are found here. Now this understanding, it has been possible with respect to the quantitative revolution and the inclusion of positivism in geography, which was majorly done by Sheffer. Okay, so this is first part where we can see that, which is quite important for understanding the interior of Earth with respect to indirect sources of seismic waves. Now, next here we have the gravimetric data. What is gravimetric data? It is the gravitational anomalies revealing density variations. Okay, here, for example, there is negative anomaly in trenches, while there is a positive anomaly in mid-oceanic ridges. Okay, so here we see that this data, it is also supported by isostasy theories. Okay, where we'll be seeing that the Ares model, it provides that the crust floats based on thickness. While the Pratt's model, where the crust floats based on density. Okay, then after this, the next important data here we have, that is geothermal gradient. Okay, so under the geothermal gradient, we see that as we go to the deeper layers of the earth, here the temperature, it increases. Okay, and it increases almost, we can see here near the crust, it is 25 to 30 degrees Celsius. In the mantle, it is 2000 degrees Celsius. In the outer core, it's 4000 degrees Celsius. And inner core, okay, it is almost 6000 degrees Celsius. Okay, so this is the average temperature which is present inside the Earth's various layers. Okay, so this is an important aspect which is also specifying that how there is variations in the Earth's interior. Now, next part here we have with respect to geomagnetism. It is also giving us certain evidences with respect to indirect sources about the interior of Earth. So here we have first part, that is dynamo theory. Now dynamo theory, it specifies that the outer core is liquid in nature, which is helping in the generation of magnetic field. Okay, this theory it is provided by Elsar, Elsar and Bullard. Now, after this, we also have the aspect of paleomagnetism. Under this, it is confirming the continental drift, with the presence of magnetic strips. Okay, at mid-oceanic regions. Okay, thus it is validating the seafloor spreading and specifying the asthenosphere. It is liquid in nature. Okay, due to which there is outpouring of magma and formation of new oceanic crust. Okay, so this is one part, and this is also related to the plate tectonics model here. Okay, now we will see that certain data and key insights which we have with respect to the method of understanding the interior of Earth So this is an additional data. You can use it for formation of nodes. Okay, so I'm giving a star mark here for nodes formation. Here we'll be making a table. We have method, key insight, example, and source. So first we have seismic refraction. Here, the layer of boundaries. It is understood. Now, sources like USGS, earthquake, data. Then we have heat flow, which is providing crustal and mantle gradients. That is the temperature part, heat gradient. This is provided by International Heat Flow Commission. Okay, you can check this data there also. Then we have gravity anomalies. Here, isostasine crustal thickness. Okay, this is provided by Grace satellite data. Very important. You can put a star mark on this one. Then we have paleomagnetism. Which is providing seafloor spreading and plate motion. Provided by Wine and Matthews. Okay. And IODP ocean core drills. Okay. So this is an important data which is taken from that particular site. Okay. Now, concluding this answer, here we'll be seeing that the direct evidence is spatially limited. But here we'll be seeing that the indirect method, especially the seismic waves study, offer a reliable multi-dimensional view of Earth's interior not only in composition but also physical state like solid and liquid. Okay, helping us to understand the Earth's interior. Guys, so this is one of the answer. Okay, this is the answer for first question, that is evaluate the role of direct and indirect sources in deciphering the composition and physical state of Earth's interior. So here we see that majority of the students for indirect sources, they are majorly focusing on seismic waves and the data which is collected from the meteorites. Okay, I have not included it here because I am looking at other important sources like gravimetric data, geothermal gradient also here. Apart from that, geomagnetism. So how this data help us to understand the interior of Earth? We can see it here. Okay. So moving to the next question. Here we have discuss the role of seismic waves in understanding the Earth's internal structure. How do variation in wave velocities help identify different layers of Earth? So this is the question. Now we'll be looking at a PYQ. Bring out the relevance of seismic study in determining the structure of the interior of the Earth. So this question, I think it was asked for 15 marks. So we'll be writing this answer for 15 marks. Okay, take 7 minutes. Try to write the answer for this question, then we'll discuss it. Okay, guys, so let's uh, look at the answer. So the question, if we look at, discuss the role of seismic waves, first keyword, in understanding the Earth's internal structure. How do variations in wave velocities help identify different layers of the Earth? So if you look at this part here, we can understand it and we can relate it with the elastic rebound theory. So according to Reed, in elastic rebound theory, which interprets the seismic waves due to earthquake generation. Okay, so here we can use the elastic rebound theory here, and is vital in understanding the dynamics of Earth's interior, like composition, density, state of matter, and temperature, comma, which is analyzed by changes in velocity, path, and amplitude of seismic waves. Okay, so this is our introduction where we include one of the theorists, the name of the theorist. Okay, we can also look at the interpretation of seismic waves, which is occurring because of the generation of earthquakes. Okay, and here we can understand the dynamics of Earth, like composition, density, state of matter, temperature, analyzed by changes in velocity, path, and amplitude. Okay, so by this we are able to better understand and interpret the internal structure of Earth. Now, moving forward, if we look at the question, here we need to discuss the role of seismic waves in understanding the Earth's internal structure. Now, let's look at the internal structure of Earth and how the seismic waves are helping us to understand and interpret these structures. So, for example, this is Earth. Now, in the interior part, to understand this better, This blue color, this will be taken for S waves, and the red color, it will be taken for P waves. Now we already know the characteristics of P waves and S waves, that S waves, they pass through solid medium only, while the P waves, they pass through solid, liquid, and gas. So in this part, what we will see that if we see that we have generation of earthquake at this particular point, so this is the point of epicenter. So from here, there will be propagation of waves. Okay, both the waves, not only S waves, but also the P waves will also propagate here. Now what we will see that the P waves will be faster waves. Okay, and it will be followed by the S waves. So this is P waves and this is S waves. Now let's look at the part here. So what we'll see here that in the initial part, as the P waves, they will propagate. So as they move inside the interior of Earth, there is one phenomenon is taking place. For example, this is one material and this is another material. So this material, it is denser, okay, because it is under higher pressure, and this material, it is lighter. Now what will happen here, as the waves, they will come in this region, okay, as there is change in the density, okay, as there is change in density, so here we'll be seeing that there is change of angle, of refraction. This is the phenomenon of refraction which is taking place here. Along with this, what we'll be seeing that this is velocity 1 and this is velocity 2. So here the velocity 2, it will be higher than velocity 1 because this material, it is denser than this material. Okay, so in the interior of Earth only we can see that as we move towards from the crust towards the core, so here the density, it increases. Okay, so let's look at this part here. So as we are moving towards the interior part, we see here that there is increase in velocity. Also, there is change in the angle of refraction which is taking place in the P waves. Now, let's look at the internal part here. For example, the P waves, they will be moving in a very simple manner as they are present in the mantle layer. But as they enter the core, as they try to enter the core, here we'll be seeing that there is one phenomena is taking place. The P waves, as they enter the core part here, their angle of refraction, it changes. Okay, as they enter the core, that is outer core. Here, the velocity, it declines. So here we'll be seeing that the declination or the decline in the velocity, it is taking place from 13 meter per second to 8 meter per second. Okay, so this is one of the, sorry, this is not meter, it is kilometer. Okay, make the note of it. It is kilometer per second. So there is decline in velocity, but as it enters the interior part here, the velocity again increases from 10 to 13 kilometer per second. Okay, so this is one thing which is observed as the P waves, they are entering in the outer core region. Now, moving forward, as this P waves, they again enter the core region. So here, as they enter the inner core, here the velocity, it sharply increases. Okay, there is a sharp increase in velocity here. So we will see that the P wave speed, it moves beyond 13 kilometer per second again to 17 kilometers per second. Okay, so this is the speed of P waves. Now it is highest at the point near the central point of the core, and then again it declines. Okay, so in this way we are able to form the profile of P wave here. Okay, so this is the profile of P wave. So here we'll be seeing that the profile of P wave, it is present between almost 105 degrees to 145 degrees. This is 105 degrees to 145 degrees. Okay, this zone, this zone, this is also called as the shadow zone of P waves. Now, looking next at the S waves. So S waves, they will be also moving similar to the P waves in the mantle layer. In the mantle layer, they will be moving very smoothly. Their path, it will be changing along with the velocity as they are moving from denser material to more denser material. Okay, and here we'll be seeing that as the waves, it moves from denser to less denser material. So there is again change in the angle of refraction here. So because of this, what we see that as this S waves, they try to enter the region of the outer core. Here they are stuck and they cannot enter the S wave. Why? Because the outer core, it is liquid in nature. And here we can see that the S waves, they can propagate only through the solid mediums only. Okay, so S waves, they are not allowed to enter the liquid outer core. So because of this, here we'll be seeing that there is, okay, I just want to make this more precise. So this is 105, this is 105. Okay, and there is a shadow zone of S wave is also formed, which is from 105 degree to 105 degree. Okay, so this is the shadow zone of S waves. So here through these seismic waves, we are able to understand, number one, the velocity pattern, the density pattern, the nature or the composition of material. The nature and the composition of material, where it is solid, where it is liquid. Okay, so this also we are able to understand by this diagram here. Now let's continue with the answer. What we find here, that is more important. So here we need to make a note that there is key seismic discontinuities. Okay, number one, the Mohovoric discontinuity, which is present in the crust mantle boundary. Okay, here this is basically discovered by Mohovoric in 1909. His name is Andrea. Okay, so here we'll be seeing that there is a sudden increase in P wave velocity, which is almost around 6.5 kilometers per second to 8.1 kilometers per second. Okay, so this is the first important part which we see as a part here. Now here we'll be seeing that according to the temperature profile, the temperature in this region, it is ranging from 200 degrees Celsius near the crust and 700 degrees Celsius near the upper mantle. Also the density for it, the crust of continent, it is having a density of 2.7 grams per centimeter cube, while the oceanic crust, it is having a density of 3.0 grams per centimeter cube, while the upper mantle, it is having a density of 3.25 grams per centimeter cube, which at the depth is ranging to 4.5 grams per centimeter cube. Okay, so this was the first part, that is the Moveric discontinuity. Now, number two here we have, that is the Gutenberg discontinuity. So under the Gutenberg discontinuity, which is present between the mantle outer core boundary. Okay, so here we can see there is the presence of, this is Gutenberg discontinuity, and here we have the presence of almost around 100 kilometers. This is Mohovoric discontinuity. Okay, so under the Gutenberg discontinuity, number one, the S wave shadow zone. It is present almost around 105 to 145 degrees. Okay, which is specifying the liquid nature of outer core. Okay, where number two, the P waves, they are refracting. Okay, which is specifying the drastic change in density. So density change here will be seeing that in the lower mantle, the density is almost around 5.6 grams per centimeter cube, while the outer core, the density here, it is almost around 9.6 to 12.6 grams per centimeter cube. Okay, so this is the second aspect which is providing us the profile here. Also, we can add the temperature. I'll add it here only. The temperature at the lower mantle, it is almost around 3700 degrees Celsius, while at the outer core, it is almost around 4000 to 5000 degree Celsius. Well, we'll be seeing that the temperature at the crust, it is around 200. Okay, so 200 temperature is already specified here. For the crust, it is 200 to 700 degrees Celsius. Then for the upper mantle, it is almost around 2500 degree Celsius. And for the lower mantle, it is 3700 degree Celsius. Okay. Now, next, let's move to the next discontinuity, that is the Lehman discontinuity, which is a outer inner core boundary. So here we'll be seeing that number one, S waves do not propagate. Why? Because they are stopped at outer core. Therefore, they are not entering inside. Okay. Number two, the P waves, they see a sudden increase in density, in velocity. Okay. If we look at the velocity part here, it is here we can see the velocity part. It is moving from 8 kilometers to 13 kilometers here. 8 kilometers per second to 13 kilometers per second at the core. That is the inner core. Okay. Apart from this, we'll be also seeing that the density at the outer core, it is almost around 9.6 to 12.6 centimeter grams per centimeter cube. Okay, while the density at inner core, it is around 13.6 grams per centimeter cube. If you look at the temperature profile, it is around 5000 degrees Celsius, while at the inner core, it is moving from 5000 to 6000 degrees Celsius at the center of the core. Okay. Apart from this, if you look at the velocity of the P wave, so P wave velocity here, we see that the P wave velocity, it is almost around 13 to 17 and 13 to 8. So here we can take an average part. So velocity here at the outer core, it is 8 to 13 kilometers per second, while at the inner core, it is greater than 13 kilometers per second. Okay, so this we can see at this particular inner core region here. Okay, so here we are able to understand what we are able to analyze. Now let's look at the question again. So discuss the role of seismic wave in understanding the Earth's internal structure. How the variations in wave velocities help identify different layers of Earth. So here we are able to identify the different layers of Earth, different discontinuities. Okay, we can understand this with the diagram here. Okay, which helps us to determine that how this system it is working. Now, for your convenience, I'm drawing you a diagram so that it will become more clear to you that how this diagram should be represented. Now here, this is the first layer, that is the crust. Okay, crust, it is extending up to 80 kilometers. This is 0 kilometers. Okay. Now, the upper mantle, it is having a reach up to 700 kilometers. Okay, this is upper mantle. This is crust, and here up to 400 kilometers, we have asthenosphere. Okay, up to 400 kilometers. Then up to 2900 kilometers, we have the presence of outer core. Now, from 2900 kilometers to, sorry, this is upper mantle and this is not outer core. This is, I just wrote here by mistake. This is inner core. Okay, then 2900 to 5100 kilometer, we have outer core. I can wrote outer core here. This is inner mantle. This is outer core, and up to 6371 kilometer, we have inner core. Okay. Now, when we look at the discontinuities which are present here, the first discontinuity which is present between the upper core, the crust, and the upper mantle, which is present here. This is Mohovoric discontinuity. Then after this, between the upper mantle, between the mantle and the outer core, we have here the Gutenberg discontinuity. And between the outer core and the inner core, we have the presence of Lehman discontinuity. Okay, so here if we try to draw, add other aspects here, for example, here the density, it is for ocean is 3 grams per centimeter cube, and for continent it is 2.7 grams per centimeter cube. For the asthenosphere part, it is almost around 3.25 grams per centimeter cube. Okay. Apart from this, if we go to the upper mantle region, so upper mantle region, it is extending up to this region. Here we have 5.6 grams per centimeter cube. And as we go to the lower mantle, here we have 7.0 grams per centimeter cube. As we move towards the outer core, here we have 9.6 grams per centimeter cube, then 12.6 grams per centimeter cube. And as we move into the core, here we have 13.6 grams per centimeter cube. Okay, so this is a profile which we can see here. If you look at the temperature variation, so temperature, I am taking here yellow color. Okay, so temperature will be almost around 27 degrees Celsius. Then at 80 kilometers, it will be 200 degrees Celsius. Then it can range up to 700 degrees Celsius at certain point. Then at the upper mantle part, it can range from 700 to 2500 degrees Celsius, then 2500 degrees Celsius to 3700 degrees Celsius, 37 degrees, 100 degrees Celsius to 5000 degrees Celsius, then 5000 degrees Celsius to 6000 degrees Celsius. So here in this part, we can cover almost the temperature, density, discontinuity. Okay. If we can see here the velocity part. Okay. So velocity part, we have for two part, that is the P waves and S waves. Okay. The velocity is also covered in this aspect here in these regions. So you can take the cue from those particular aspects there. Okay. Now, let's look at the conclusion part. So I'll just take this conclusion in the next page so that the continuity is maintained. So under the conclusion, what we can write here, the seismic waves basically helps us to understand the interior of the earth, where the vibrations which are occurring because of the earthquakes, it is helping us to understand the nature of the nature and composition and the physical state of the interior of the earth, which is helping us to understand the layered structure of the earth. So we will be writing the same thing here. The seismic waves are the important developments during the quantitative revolution, which helped to map the interior structure chorographically and chorologically, and helping us to understand the varied composition, temperature, density, discontinuities, etc. within the internal layers of Earth's structure. So by this note, we can complete this answer, and we can see that how it helps us to understand this answer in a better way. Okay, so you can note the various points of this answer. Okay, do write the answer and send it to me. Okay, so guys, I'll be ending this session now. Do uh, do provide me the feedback that how did you like this session, and do join the session. Do share it with your friends so that this answer writing, it can benefit a lot of students here. Okay, so guys, see you in the next class. Thank you.